Here we are on the first video of Chapter 4, and we're going to bypass sections 1 and 2, but realize if we need to, we might need to go back and just grab certain aspects of that. However, realize that we should be able to get by with the added information and everything. So we look at example number 1, we need to match the graph to one of the listed functions. And as we looked in Chapter 3, we are able to do our graphing by shifting, compressing, stretching, and or reflections, and that's all we're asking to do here. We have to understand that on number 1 we have a parabola going down, so that means the x squared term would be negative, so that throws out a and d as far as the multiple choice goes. And then we see that it is shifted 2 up, and so it would be negative x squared plus 2, and the answer would then have to be B. And then we look at the other problems in the next group, 2, 3, and 4. Here we're going to be using any of the transformations. We start out with x squared, which we should remember begin with the points 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and if we have the chance, 3, 9, and negative 3, 9. And so we've got these points to begin with. Then we look at number 2, which is f of x equals 1/5 x squared. Well, x squared, this is the parent function. Then the 1/5 simply means we're going to compress all of these y values to 1/5 of the value. Remember that the 1/5 is not directly connected to x, because we'd have to have parentheses there, and then something else would happen. But here we're going to compress those y values. So 0 is going to remain 0, but 1 becomes 1/5, 4 becomes 4/5, and 9 becomes 9/5. So this parabola becomes extremely flat, even almost to the point where it looks like absolute value. But we have to remember that this is a parabola. It's just a very flattened out parabola. Number 3 asks us to do the same thing, just with different values. So number 3, we have f of x is equal to negative x squared minus 4x. Well, the first thing we have to do is to get this in to where we can use the transformations. And in order to do that, we do need to complete the square here. So we're going to, first of all, bring out a negative from everywhere. So that would be negative x squared plus 4x. We're going to leave a little bit of room. And in fact, we're going to complete the square. Completing the square here, we take half of this is 2. 2 squared is 4. But realize what we just put into the mix was not a positive 4, but instead a negative 4. So to offset it, we have to add 4 out here so that we haven't changed the actual value. Then just cleaning this up, we get negative x plus 2, the quantity squared, plus 4. And so remembering that things that happen, first of all, this negative here will make it reflect over the x-axis. This right here is with the x, so it doesn't behave. So normally it would seem, let's go to right. Instead, we're going to go to left. And this one does actually behave and tells us to go 4 up. And so we have the parent function with the points 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and the 3, 9, and negative 3, 9. But we're told, let's go 2 left and 4 up. So this is going to become our new vertex right here. And then, well, we would need to do a reflection first. So, well, but reflecting the vertex doesn't do that. But when we reflect over here, we end up, basically, we're just moving down. Is what's happening. And so, and it's a very poor drawing, but that's the best I can do with the particular writing utensil that I have. So, we are ready to go on with the next section, or pardon me, the next problem. Number 4. Number 4, we have f of x equals negative x squared plus 10x minus 18. And the first thing we have to do is to get it into a usable form. Well, we need to pull that negative out, so that's going to be x squared, and we have to change the sign so that we haven't changed anything, plus, and then we're going to complete the square eventually, but we have this minus 18 out here. So completing this square, this would be plus 25, but what we actually put in was a negative 25, so to compensate for that, we're going to have to do plus 25 out here. Writing this into a user-friendly form, we get negative x minus 5 quantity squared plus 7. And so this allows us to say, okay, this is going to tell us reflect over the x-axis. Go 5 to the right and go 7 up. And that is all from what we have looked at back in chapter 3. We know our parent function is x squared. So what we need to do is just graph the parts. Making my original points here. Reflect, go 5 right and 7 up. So we're way up here. I know reflection is going to cause it to come downwards, or the way I like to look at this is the fact that if I draw a new set of axes there, then all I have to do is use those values and I will get that particular drawing that looks something like that. Now, suppose that we are given just the equation, and we are asked, as we are in problems 5 and 6, find the vertex and the axis of symmetry. The vertex is really simple, but what we can do here is the first thing we want to do is we want to find the x value for that vertex. Well, the x value is relatively simple. To find the x value, all we really have to do is take negative b over 2a, using the fact that this would be the a coefficient, this would be the b coefficient, and remember that if we had a constant, that would be c. These are using the same a's, b's, and c's as we do in the Pythagorean or in the quadratic formula. So to find the x value, all we have to do is realize, okay, we've got negative, b in this case is 10, 2 times, okay, a is negative 1. So we get negative 10 over negative 2, which equals 5. Now once we find the x value, the y value, the simplest way to do that is just plug it into the equation. F of 5 would be negative 5 squared plus 10 times 5, which equals negative 25, plus 50, which equals 25. Now there is another way. What we could do is we could take, or we could use other values. We could take 4 times a times c minus b squared all over 4 times a. But why when we can do that? I realize that may come in handy a little bit later. But to finish this particular video, I'm going to do the 6th example. And so f of x is equal to negative x squared plus 6x minus 5. And so to find the x value, or what we call h is the x value, k is the y value, h is equal to negative b over 2 times a. Negative 6 over negative 2, which equals positive 3. And to find k, all we have to do is find f of h. So that'd be negative 3 squared plus 6 times 3 minus 5 equals negative 9 plus 18 minus 5, which equals 4. And so the vertex here would be 3, 4. Now I do have a slight problem. I did not answer what is the axis of symmetry. Well, and I'll go back and finish 5 here shortly, but number 6, we have the vertex is 3, 4. The axis of symmetry will be x equals whatever the x value is, 3. X equals 3 is the axis of symmetry. So now, working my way back up here to example number 5, I know that x value, or the h, is equal to 5. So the vertex would be 5, 25, and then the axis of symmetry would be x equals 5.